In section 4, we're going to look at properties of quadratic relations, and we're specifically going to look at key parts of graphing a quadratic and how to go about graphing a quadratic equation. So the first thing we're going to talk about is parabola, and parabola is the term for the shape of a quadratic. So you can have two different shapes of a quadratic. You can have a quadratic that opens up, which is a regular U, or you can have one that opens down, which is an upside down U. Okay. Depending on which direction the parabola opens, we have something called the vertex. So it's either the highest or lowest point of a parabola. Now, if a parabola opens up, the vertex is this lowest point, and if the parabola opens down, the vertex is what we call the highest point. And then lastly, we have the axis of symmetry. So the axis of symmetry is the vertical line that mirrors a parabola. So all parabolas, because they're U-shaped, there's a point at which they mirror each other. And that point is called the axis of symmetry. And it always passes through the vertex. Okay. And if you're trying to calculate the axis of symmetry, the formula is x equals negative b over 2a. So if you want to find where your axis of symmetry is, you can do that. So if I'm going back to my original pictures here, my axis of symmetry goes through that x value of my vertex, which I can also calculate mathematically. Okay. So let's do some examples where we graph parabolas. Okay, so we have the equation y equals x squared plus 2x minus 1, and I want to graph it using a table of values. And I want to make sure that one of those values is the x value for my vertex. So the first thing I'm going to do is find that x value. So I'm going to label a, b, and c. I don't need a, b, and c. I just need a and b. So my x value is going to be negative b, so negative 2 over 2 times a, which is 1. So that gives me negative 2 over 2, which is negative 1. So when I go to graph my parabola and I have my x and y values, I want to make sure I do negative 1. I'm going to do 2 values below that, and I'm going to do 2 values above that. So I'm going to use the points negative 3, negative 2, negative 1, 0, and 1. Now I'm going to go ahead and plug those values into my equation to solve for my y values. So I plug in negative 3. I do negative 3 squared plus 2 times negative 3 minus 1. So I'm going to get 9 minus 6 minus 1. So it's going to be 9 minus 7, which is going to give me 2. Now I'm going to plug in negative 2. Negative 2 squared plus 2 times negative 2 minus 1. So negative 2 squared is 4. Minus 4 minus 1, which is going to give me negative 1. Then I plug in negative 1. It's going to give me 1 minus 2 minus 1, which is negative 2. And I'm going to plug in 0, which is just going to give me negative 1. And then I'm going to plug in 1, which is going to give me 2. So another nice thing, because I've included my axis of symmetry, I can see that mirror. So as I move from the vertex, the x values mirror each other, so they end up being the same. So when I go to graph it, I have my x-axis and my y-axis. I'm going to go to negative 3, and then positive 2, negative 2, negative 1, negative 1, negative 2. 0, -1, and then 1, 2. And I'm going to connect those points. And I'm going to have my parabola. Okay. Now, based off this graph, I can now identify some information. So the first thing I want to know, does it open up or down? And I can tell that it opens up. Okay, I also, because I've graphed it, I can identify the vertex. I already knew the x value of my vertex was at -1, and now I know my y value is at -2. Okay. And now my axis of symmetry, which we already found, x equals -1. Now it is important here when we do axis of symmetry, we always include the x equals, because the axis of symmetry is a vertical line. It is an equation. You have to have x equals. Okay. Now what if I don't want to graph the equation every time? So what if from the equation I want to know if it opens up or down, where the vertex is, and where the axis of symmetry is? We can do that. So we have y equals -3x squared minus 6x plus 3. So if I want to determine what direction my parabola opens, I'm going to look at the a value. Okay. More specifically, if a is greater than 0, it opens up, and if a is less than 0, it's going to open down. So in our case, a is -3, which means it's less than 0, which means the parabola is going to open down. When I want to find the vertex, I'm going to go ahead and find the x value using my formula, -b, so -6 over 2a, so 2 times -3. -6 is going to become +6. 2 times -3 is -6, and I'm going to get -1 for the x value. To find my y value, I'm now going to plug that in. -3 times -1 squared minus 6 times -1 plus 3. I get -3 times 1, which is just -3, plus 6 plus 3, which is going to give me 6. So that tells me my vertex is at -1, 6. And then my axis of symmetry is the same as the x value from the vertex, so x equals -1. You can also find the axis of symmetry first and then find the vertex. Those are kind of interchangeable in their process because we technically find the axis of symmetry while we're calculating the vertex. All right, now we're going to talk about a different form. So far we have discussed standard form for a quadratic equation, the y equals ax squared plus bx plus c. But there is another form that is actually useful to us if we are graphing quadratic, and that's vertex form. And it helps us to identify where the vertex is, and I can use that to help graph. So the general form for vertex form is y equals a parentheses x minus h squared plus k, and then the vertex is the point hk. So we're now going to use the vertex form to help us create our table and graph our quadratic. So we have y equals x plus 1 squared minus 2. So key thing here, when I'm identifying the vertex from vertex form, because the formula is normally minus, and identify my vertex is like whatever is inside the parentheses with x when it's being subtracted is the x value, and whatever is outside when it's being added is my y value, my h and my k. If I have the opposites of those, that's what it's going to be. So a plus 1 inside the parentheses tells me I actually have an x value of -1. And then a value of -2 tells me I have a y value of -2. And now I'm going to do the -2, -3, and the 0, and the 1. It is a little bit easier here to plug in my x values. So I'm going to do -3 plus 1, which is -2. When I square it, I get +4. -2 is going to give me 2. Now I plug in -2. -2 plus 1 is -1. Squared is +1. -2 is -1. 0 is going to give me 1 squared, which is 1 minus 2 is -1, and 1 is going to give me 2. So I go to graph it. I have my x and y axis. I go to -3, 2, -2, -1, -1, -2, 0, -1, and 1, 2. So I can see it's the exact same graph. It gives me, it's the exact same graph that I had from my first example, but I used a different equation. It actually got me to the graph a little bit quicker because I didn't have to start from scratch. I didn't have to start by calculating the x value of the vertex, and it was a little bit easier to plug values in for x. Okay? We can still identify the same 3 pieces of information, what direction it opens, the vertex, and the axis of symmetry. So again, because we have it graphed, we can see that it opens up. Right? We have identified the vertex as -1, -2 from the formula and from the graph. And then my axis of symmetry is at x equals -1. So again, what if I choose not to graph the equation first? How do I identify those same 3 things? Well, I can still identify whether it opens up or down by whether or not A is positive or negative. So A is positive, it opens up. A is negative, it opens down. In this case, A is -1 because I have that negative in front. So when I have y equals -x minus 4 squared plus 7, it's going to open down. When I identify my vertex, I don't have to use the formula, I don't have to plug it in. It's the opposite of what's in the parentheses, so it's a -4, so it's going to be 4. And then it's a +7, so it's 7. And then the axis of symmetry is going to be x equals 4. So vertex form is very nice. It's a little bit quicker to identify the vertex, the axis of symmetry. It's a little bit quicker to graph. So vertex form is a little bit more helpful than just the normal standard form of a quadratic. Now, last thing we want to talk about is how do I go from standard form to vertex form? And we're going to use part of the process of completing the square because I want that parentheses with the squared, and the only way I can get that is by doing some of the completing the square process. So the first thing I'm going to do, so my example, y equals x squared plus 2x minus 7, is I'm going to separate in parentheses the part of the equation that has the x's from my constant -7. Okay, so I have x squared plus 2x, and I'm going to leave a little bit of a space because I want to complete that quadratic as a perfect square trinomial. So I'm going to do the b divided by 2 squared just like when we would do completing the square. So I'm going to do 2 divided by 2 squared, which gives me 1 squared, which is 1. Now, if I add 1 inside these parentheses, instead of also adding it like the last step where we were adding it to one side so we had to add it to the other, if I add 1 inside the parentheses, I now have to subtract 1 outside the parentheses. Because if I were to drop those parentheses and combine like terms, I want to get x squared plus 2x minus 7. When I factor what's in the parentheses, it's still going to factor as x plus b over 2 squared. So in this case, x plus 1 squared. And then I'm going to go ahead and combine -7 minus 1, and that's going to give me -8. And that's my equation. And I can now identify the vertex as -1, -8. I want you to go ahead and pause now and see if you can try this last example on your own, and then go ahead and check it with my work. First step, we have x squared plus 6x minus 8. We're going to write x squared plus 6x in parentheses. We'll put our minus 8 outside. We're going to do 6 divided by 2 squared. So we get 3 squared, which is 9. So I'm going to add 9 in the parentheses and subtract it outside. When I factor, I'm going to get x plus 3 squared, and then -8 minus 9 is -17. So my equation is y equals x plus 3 squared minus 17. And my vertex is at -3, -17. Let me know if you have any questions about graphing quadratics in either standard form or vertex form, identifying the direction it opens, the vertex, or the axis of symmetry from either standard form or vertex form, and then of course converting from standard form to vertex form.